This talk is covering the SQLAlchemy ORM. So start out with defining what is an ORM. It stands for Object Relational Mapping, which basically means it's a object-oriented around tabular data. That's the most common ORM scheme. So you got the object, and then the relational would be the relational database. So it's the bridge between the two. Most commonly used represent SQL databases. So that's what we're going to be looking at here. The benefits of using an ORM: you get a more idiomatic interface between your data and your application language. Removes the need for long string queries mixed into your source code, which some people like, I guess. I personally do not. I don't like mixing languages in one source file, and a lot of times you don't even get syntax highlighting on your SQL query, stuff like that. It abstracts away differences between database backends because every SQL backend has its own version of the SQL language, so to some extent, an ORM can hide those differences. It allows dynamic query building without string manipulation. So for example, if you want to conditionally apply a filter or where statement, you can do that without trying to do string building to get a SQL query, which can be finicky and potentially dangerous. Which brings me to the last point. It can reduce the risk of SQL injection. So those are a few benefits of an ORM in general. The benefits of SQLAlchemy ORM. There are a few that may be a reason to choose SQLAlchemy over other ORMs like Django's. I find it to be a more flexible ORM than any other I've used. The expressions, when you write it, it actually resembles the SQL that it will generate, which means you can predict the query that's going to be sent to the database, allowing you to optimize better and more easily reason about it, and you don't have to learn a whole new expression language like kind of got to do with like Django or something, their F expressions and things like that. Very extensible and customizable. Like there's hooks everywhere. You can override almost anything in there. If you want to get really advanced, mostly you don't have to, but the options available. And it's integrated with many libraries and frameworks. Works with, I think, NumPy. Works with like their extensions to Flask. Like there's serialization libraries that work with it. Tons of stuff. Very, very common framework. Very common library. All right. So let's get to some code here. See if I can have that not get cut off. Everyone still read that? Yeah. Okay. So this first section's mainly some boilerplate kind of stuff. Import the library, import this function here, because for some reason you can't access it through just use .access, whatever. So first step, we create the engine. The engine contains all the information of how to connect to your database and how to actually, run a string query in the database. Well, I guess that's not necessarily true. This is the thing that actually makes the connection to the database. And below that we have, and the echo true is helpful. I'm going to be using that so we can see the output that actually is executed. That's fairly useful. And here I'm using a simple connection string, just going to a SQLite database. You can connect to, I think they got backends for Postgres, MySQL, Oracle, Microsoft SQL. So yeah, there's tons of backends you can use to connect to all different databases. The session below this, the session sort of represents a connection to the database. It goes to the engine, asks the engine for a connection, and then the session manages that connection. It tracks the ORM objects, keeps track of what's new, what's modified, what's been deleted, and it also manages the transaction that's currently open. So yeah, it's just some boilerplate to make a session, and then below that we just have a base class for all our ORM classes. So we'll just be inheriting from that. All right, so quick sidebar about sessions and transactions in SQLAlchemy. Every query by default in SQLAlchemy is run inside of a transaction. Transactions are created implicitly, so you can be sure that everything you do can be rolled back until you commit, and typically you will manually commit. There is an auto commit mode. I've never personally used it. I prefer to manage the session or manage the transaction separately. All right. So yeah, each session always has a transaction. Transaction will last until commit or rollback. Then the next time you use the session, new transaction. And the session maintains the list of new, modified, and deleted ORM objects, and it will only issue queries to the database when it needs to. When you either flush or commit, or a query needs to run and you need the data to be synchronized to the database for accurate query results. So yes, it is lazy about actually accessing the database, which can be a performance benefit. It can also sometimes make it hard to debug things because maybe something, you don't get the error immediately where your query might have found wrong, but that's usually not a big problem. Usually you can trace it back. All right, so let's define our schema. This is a SQLAlchemy typically uses a declarative interface. This, for those of you who have experience with Django, this might look kind of familiar. So we create a band class where we're going to be making a basic music library here. Grab some data from the Spotify API and we'll be messing with that. So we'll create a band, we inherit from the base class, define a table name. This is what's actually going to be used in the database. Define our primary key. The primary key can be, well, you always need a primary key when using the SQLAlchemy ORM. This is how the session tracks which object is which, and make sure that the record you're accessing is the one that's getting updated, things like that. The primary key can be anything. It can even be a compound key, just as long as it's unique. That's fine. And then below that we have a column definition, just a varchar 255, not null and unique constraints. And below that we just got a repr function, so we can see a nice print value. Okay, then we define an album. For the most part, this is basically the same as the band class, but here we have a foreign key linking to the bands table. Something maybe to note is the foreign key is not actually a column type, like integer or Unicode. What's happening is that SQLAlchemy can look up the band ID here and determine the type and automatically provide it. We could provide a type that could be different, but SQLAlchemy just helps us out there, and that's what we want usually. And we define the onDelete. You could, I think by default it goes to onDelete, set none, or set null. But when we delete a band, we want to delete the albums as well, so that's what we go with. All right, and then because we don't want to have to go through the business of accessing bands by their ID from the album, we're defining a relationship. This relationship here will give us a bidirectional link between the objects. This is a many to one, or one many, whichever way you look at it. So we just tell it we want to link to the band. SQLAlchemy here is able to determine that since we only have one foreign key to the band table, we probably want to use the band ID, so it'll default to that. If you have more than one foreign key to the same table, you can just pass it a couple arguments that define which foreign key you want to use. There's a lot of options to use in a relationship object. You can change, by default, a lazy load. You can change it to eager load. You can change it to you can switch between loading with joins or loading with subqueries. You can define intermediate table. You can completely customize the join statement it uses. There's a lot of options there, so it's a very flexible system. And then another wrapper method. So that we got the song. Very similar to everything else we've seen so far, just foreign key to the album table, and so here we have a more complicated backgraph here. By default, if you provide a backgraph string, it'll add a attribute on the other object, on the linked object. So here it'll add a songs attribute, which you can access, which is like a list, which you can treat like a list of song objects. And we define an order by there, just by default. I should probably execute this code actually. Otherwise, didn't import anything. Okay, so here we start to see SQLAlchemy actually executing something. Here's just gathering some information because it's its first connection, just gathering information about the database. Oh, I forgot at the bottom here. We call base metadata create all on the engine. This actually executes the create table statements for anything that's not, for any tables that aren't currently in the database. This will create them. It's useful for small projects and debugging. For bigger applications, there's a migration system called Alembic that you can use, and but we won't be getting into that, so we'll just create one like this. So here's checking for the presence of the tables, and none of them exist yet. So create the bands table, create the albums table, and create the songs table, pretty much like we expect. And so, since we want to actually have some data here, place that with the table or the database I've already populated. Alright, so here we're going to retrieve a single record by ID. Pretty simple. We tell the session we want a query. It creates a query object. We're telling it we want a band, and we say get, which gets an object by the ID. It's just a convenience method. It will create a query with the filter on the ID. Well, I guess another benefit of get is if SQLAlchemy has already loaded that record, it can just retrieve it from its cache by the ID if you get it by the ID. So this won't always execute a query, but since we haven't loaded it, it will here. And so we see we begin a transaction implicitly because this is our first query. We don't have the transaction started yet. And here's the query it executes. Gets all the columns, selects from the bands, and filters by the ID. And these are the arguments that go to it. Use some question marks for variable replacement. And now that we have the band object, we can access its attributes like any other Python object. So we can get the name, and we can iterate through the albums. So we got the band The Beatles, and here we see it's gathering the albums. It's by default lazy loading the albums, so it's generating a query here to get them. And here's our output. Got 15 albums here. Alright, so that's getting one object. If we want to get all of them, we just create a query and just call all. Since we have no other conditions, that will get us everything. And so I've got 5 bands in here. Just 5 random things I picked out off of Spotify. So yeah, when we call all, we'll just get a list of the results. So here we'll see some filtering. We create the query object, and we apply a filter. It's worth noting the query objects are immutable, and every function you call on them will return you a new query object. This is helpful, so not just for chaining, but I guess that doesn't necessarily help chaining, but that allows you to reuse a query later, apply different filters and things like that to it, so that can reduce code replication, and just makes for a nice interface. We apply the filter. We use the class attribute, And SQLAlchemy overrides the equality operator to generate an expression object that we pass into filter. And we just call first because we only expect one record. And here's our query. You see we generated the where from the column there, from the ORM attribute, and it generated a when an offset statement there, clause there, and we get the record we expect. There are lots of different expressions you can use for filtering. There's in, like, there's greater than, equal, all the comparators you can you normally expect. So just generate a white statement here, and get 2 bands back because we just want bands with "the" in the name. You can apply multiple filters. You can use the SQLAlchemy and init functions to combine them. So we say name, if the band's name is the Beatles or it contains Simon, then we include them. So that generates our OR statement there. You can nest these and make it as complex as you want to make it. This is another way of writing the exact same query, is using more operator overloading, using the Boolean or the binary OR operator. You got to be careful with this because of the OR operator takes precedence over the equality operator, so you need to make sure you get your parentheses right there. So I typically prefer the functional version. We can see that's exactly the same query. All right, so we've been querying one table. Now let's see how we can get results from multiple tables. If we wanted to just get the related pairs of album and bands, we can do that by just adding them both to our query statement and specifying how we want to join them. Here we just say. We just compare the foreign key to the primary key of that table, and that's pretty much how you'd expect that to work. We just got all the pairs there. Probably have too much data in here. Another way to do that is just use the relationship. The relationship knows how to join the tables, so we can just use that, and we only have to specify how it should join once. And this is exactly the same query.
So that's the relationship you set up above?
Yes, this is the relationship. This is the class attribute that defines the relationship. That also works with the backref side too. Anything that works with the relationship pretty much works with its backref as well. So I could reverse this and say band.out instead. I can figure it out. All right, so we get some more advanced queries here. You might notice this is starting to look quite a bit like a SQL query, which is nice. We can guess exactly what the query is going to look like when we execute it. So here we're going to select specific fields. Before we were selecting the entire ORM object, the entire record. We don't always want to do that. Sometimes we don't need all that data. So we just pick the fields we want. So we just use the class attributes that correspond to the columns we want. So we get the band name, the album title, the song track number, and the song title. And that anything in the query kind of represents the select. You notice we don't have a from statement here. That's because by default, SQLAlchemy will select from, yeah, this is something you got to be careful about. SQLAlchemy will select from anything that's in the query call that isn't otherwise joined. Any table that's in the query call that isn't otherwise joined. So that means if you forget a join, this is kind of a bad interface, but if you forget a join, it will do a Cartesian product of the two tables, which is pretty much never what you want. So you got to be careful about that. Maybe there's a way to turn that off if you override the. You can override how the query class. Maybe you can disable that. I don't know, but just something to be aware of. But see, the first thing we're selecting is the band. So, and we don't have it in a join, so it'll just go with that. So we could, if that's not what we wanted, I think. I forget exactly. The first object has something to do with it too. The first table you select from. Typically, but if you want to be very explicit, you can specify manually like this. But that would make a difference in this query. So we got two joins here. These are by default. Join is this is an inner join. There's also an outer join function that will perform left outer join. Recently, they've added a flag on the outer join, so you can do a full outer join. That's only on the most recent versions, I think. And I don't believe there is a way to do a right join. No one uses those anyway, I don't think. I probably shouldn't be using those. So we're doing inner joins because everything's not nullable. So not concerned about that. So two join clauses. A where clause comes from the filter. We're just selecting songs with length greater than 5 minutes. And you can guess that's going to be the order by clause. Ordering by name, band name, then album title, then the song track number.
How do you specify ascending, descending, and something like that?
There's a property. I think there's an ASC property there too.
That's default. So
yeah. You don't have to use that. I think there's also you can also specify it by name. Like if I had a unique name on these, I could say if I added a label to it. And then to specify descending, I think there's a function like that. It's nicer to work with the class attributes. And so we execute it, query all, and that executes it. Maybe something I should mention is query all gets you a list back, so it executes a query, loads everything, hands you a list. The query object itself is also iterable, and depending on the back-end implementation, that can avoid loading the entire result set at once. So if we just said, we could just do that. same results. Yeah, so you can see the query here. Yeah, SQLAlchemy doesn't format it the best in the echo thing, but you can get an idea of what's going on. Okay, so aggregation. Here we are trying to determine album lengths, both in tracks and the length in minutes, duration in minutes. So we just select the name and title of the band name, album title. We count the track IDs and song IDs. Those SQLAlchemy Func, I guess it's kind of like the SA Func is just kind of an object that contains all the functions that your database supports essentially. If you try to call something that's not in there, it will try to make a function for you. It just knows how to format the function call in the database. So if it's not explicitly defined, like some databases have certain functions that are called differently, like casts or something like that. So if this SQLAlchemy backend knows about that, then it can format it correctly. Otherwise, it just falls back to trying to call any function. So if you have custom defined functions in your database, you can use those through this.
So the label you have on there would be how you denote it. Where you're talking about the ascending by the label. That's kind of how you establish the same, because that's the same naming for the column rather than using the object property.
Well, I mean, if we had a function we wanted to call on the title called foo, called foo could be a custom function or anything else, and SQLAlchemy will format that the way we need and make the function call.
No, the label's just the column.
Right. Well, I was talking about when he was referencing that in the sorting before. That's how you would get that field to go just to do that.
That specifies the as clause.
Right.
That maps the as clause. So I could do it here as well. And then in the result set, kind of like a named tuple, and so you can access it by that name or by the index, or by the column index.
By default, they'd be except like .name, .title.
By default, if you're selecting from just one table or there's no conflicts between the names, band name would be called name.
But it may be band.
But if there's conflicts, SQLAlchemy avoids those and starts naming it things that are not as predictable.
It's like dunder obfuscation type of.
I think it names it the table name underscore the column name, or the alias name underscore the column name. However, it's if it's alias, they'll probably use that. When you get into more complex queries, it's not always obvious how it's going to be aliased. So if you really, if that becomes an issue, you just slap a label on it, and you'll know what it is. Okay, so we're counting the song IDs, and we're summing up the lengths divided by 60, so we get minutes. Same old joins, order, and the group by statement. Anything that's not aggregated needs to be in the group by. Normal SQL. And run the query, get the results. And so here's each album length.
Can you show what the error looks like if you forget one of your?
Oh, sure. Wait a minute. Something up here.
The as clause you buy?
No, I don't think so. I'm not very familiar with SQLite, but maybe SQLite allows that.
It got to the first band, it only selected the first album in the band, aggregated all of the albums.
Yeah, it aggregated everything. So I guess SQLite.
Yeah, so your album name there is probably the first album, but all the rest is aggregated.
Yeah. Yep. Okay.
Make sure you do that to your coworkers. They don't know what the world's going on.
What if you leave out the group by altogether? Will your error?
No.
If you leave out group by altogether, will give you an error?
They'll give you maybe the first band, first album in your whole music collection.
Interesting.
That's exactly what happened. Or
Wow.
no, that's the last one. I think. Yeah, I think that's the last one by.
That's interesting.
As if you're using a different database back in the SQL engine
in
throws the error.
Postgres, that would be an error.
Yeah.
But
in most databases that would be an error. SQLite just has some. It's a lot more.
It's a very, very helpful database.
Yeah, it's much more forgiving than a lot of databases.
Well, what you would see returned is the actual error from the database.
Yeah, it comes from the
itself.
database. It executes it. It would come from the database and say, whatever the database error message is, parse error, whatever. It'd just be an exception. You can catch it.
Is there an error level that's kind of like a pre-validation before submitting type? So a SQLAlchemy error, but then there's a database error, or do they just throw it the best they can?
If there's a problem like converting your parameters, you'll get an error there, but there's no real validation going on.
They built the functions in a way that it builds valid SQL. It's just, not necessarily valid. It builds SQL that it can shove that in.
Yeah, it builds SQL that's, I guess,
at least
syntactically correct, but may not. Well, I guess not maybe syntactically, but the SQL generates is not always going to execute perfectly.
Right.
You will get database errors back. I'm sure that you could add on validation on top, but it's typically just, that seems extraneous. You might as well let the database do it.
Yeah.
All right. You can also use subqueries. This is a little more advanced usage, but basically we just create a query object. Here we want to know what percentage of my library goes with each band. What percentage of my library is each band by song counts. And so we need to count the songs for each band here. Just aggregation here. Just an aggregate query. And we call subquery. We can give it a name. If we don't, SQLAlchemy will generate something like a non-one or something. Not very easy to read and understand when you get more complex. So I like to give them names. And here we just query the count of the total songs. You can just call count on a query. It'll wrap it in just a count star call and give you back that, return the integer value. And we can use that subquery. We can select from it. We can join it. We can treat it very much like we would an ORM object. It's not exactly the same, because you'll notice when we access the attributes, we use this C.C thing. That's because it doesn't actually implement the ORM interface. It implements a lower level thing in SQLAlchemy called selectable interface, I believe. And basically the ORM objects wrap, a selectable interface for the table. And so this is just a slightly lower level thing. That's one of the benefits of SQLAlchemy is you can always drop to a lower level, lower level of abstraction. With the .c, which is an alias for like .columns, I think, you can select whatever we added up here. I'm using labels, and those will be the attributes here. I think if we didn't have those, I think the band ID would be called like ID, and I have no idea what this would be labeled. So, good to use labels. Okay, and then down here, we use SQLAlchemy cast it to a float, multiply by 100, divide by the total track count, get a percentage, and we'll join it. And see here, this is our count. This is the count query right here, just like start from as count 1, and then it automatically creates a subquery from this query that we made here. Just wraps it up and returns that. So I have 1024 songs. And so here's the cast.
Interesting. Anon one, did you need to label it in the call to the subquery?
No. That's this label.
Oh.
I don't have a label on this column.
Gotcha.
In this select attribute, so it's generating that. It has no idea what what to name that, so it just went with the default. So here is our subquery, and just inserts it in there and joins it. And looks like the Rolling Stones make up the most there. Another thing, kind of cool, you can use common table expressions. I prefer this over subqueries because it avoids that nesting, makes the generated query easier to read. And SQLite doesn't support that. If you're using a real database, it behaves exactly the same.
Does that have a valid error down there then? That's a SQL error?
Yes, this is a... yes.
Is that actually pointing back to your Python line numbers then?
This is just where I executed the query. If we scroll down through several layers of SQLAlchemy, a lot of calls here. Here we see the SQL error, syntax error. Because apparently that's not supported. I don't know if there's... So, but yeah, if you're using Postgres or something else, you could use a CTE, and I think it's nicer to look at. All right, so far we've been doing a bunch of querying. That's probably the place where SQLAlchemy stands out the most is the querying, but probably also want to be able to modify the database, so we'll look at inserting. So I'm going to create a new album. So a new band, new album, new songs. So we're going to create a band for John Prine. So we're just calling the band constructor, getting back a band object, This object is in no way associated with the database. Because if you'll remember at the top, when we created our base class for our ORM objects, we didn't associate that at all with the engine or the session. So right now, SQLAlchemy doesn't really know that this is, the session knows nothing about it. So it's just like a normal object. So below here, we add it to the session. We're telling the session we want to start tracking this object. Keep track of, remember that it's a new object, and next time you go to flush, make sure to insert it. And so still no data is being sent to the database here. It's just added to the session cache. Okay, create a new album. So the album constructor can take keyword args. These are the attributes on the ORM class. You can also just assign them as normal Python attributes. You can assign to the relationship. We don't have to set the ID manually. SQLAlchemy is going to take care of that for us. But you could set the ID manually. In that case, SQLAlchemy will take care of the relationship for us. So we add the album souvenirs. And let's create the song list. I just have a list of tuples here: song name, track number, and length. So just iterate through them, create them, and I'm just appending them to the songs relationship on the album. I'm not adding them to the session here. That'll happen automatically when I add them to the relationship that's already a part of the session. So technically, I don't think I need to add the album either. But just to be explicit about it. Alright, still nothing's gone to the database until we hit here where I'm telling it to commit the transaction. So what's going to happen is SQLAlchemy is going to run all the insert statements, and then it's going to commit the transaction, and that's all it's doing. So we see the insert for the band, insert for the album, all the inserts for the song table, and commit. And now if we query the songs, there's going to be more results. But you can see that we just started a new transaction because we committed our old one. So that was closed. Now we need a new one. So we execute the query, and here's the query. And because I'm in my print statement, or my repr statements, I'm referencing the band object, it's lazy loading all the bands. Because those are all expired after the session was committed. After you commit, it expires all the objects that you have currently, and it will reload them just to make sure everything is synced up with the database for that transaction. It's loading. Oh, it's loading all the albums too. Here are the results. Should be able to see our new one. New one's down here. Yep. Here are the songs we added. And the rest of them cut off. Okay. So that's how you insert records. I guess maybe I should mention you're doing a lot of them, you can add them. You can do a bulk add. There's like an add all function. You just pass a list of objects and it'll add them to the session. And SQLAlchemy will just hold on to them and batch them, and it goes to insert. Or it goes to flush. Okay, here we want to update a record. So first we retrieve the ORM object. We're just going to grab the white album. I'm going to rename it just by setting the attribute. SQLAlchemy will detect this because it's tracked by the session. SQLAlchemy will detect that the object is dirty. It will actually even detect the specific attributes that have changed. And so it will create the update statement from that. Okay, don't need to call add here or anything because it's already tracked by the session. We got it from the query. Yeah, so the database hasn't been touched yet, but it will when we issue this query because it needs to flush it to make sure we have a consistent view of the database when we actually execute the query. So before the query runs, it flushes, and then it executes the query. Just run it. And you can see here's the here's where we retrieve the object. And here's the update. See, it's using the primary key that we defined above to determine what record this update. And yeah, and here's the other select. Afterwards, and the results. Here we go, got updated. Now that's in the database, but that's flush but not committed. So we're still within our transaction. And so if I wanted to undo this change, I just call session rollback. That will just roll back the transaction and start a new one when we execute the next query, and so we'll get the old value back. So roll back, and before this query executes, before the query executes, begin a new transaction, and run the select. And as you can see, it got changed back.
Any of the objects in there linked together kind of auto-inflate. Kind of does its own join in object building. Right, like the band.
Oh, these right here?
No, if you go down, like it has the album object and then it has the band object.
That's part of my print state or my repr statement, my repr functions. I'm printing the related objects.
But when you get the actual album back, though, if you do .band, would you have that object because it's already linked to it? Does it actually get it out?
The relationships are always linked. I mean, because this is late, the relationships are by default lazy loaded. It may not be in memory, and so it may result in a separate query.
As soon as you access that
.band. Yeah, as soon as you access it.
But since your repr is actually doing it, you're triggering the query there.
Yeah, because of the printing. I'm telling it I'm touching the band here for each album.
I was trying to look at when you do the queries, you're kind of doing it in a typical database format where you're having a name tuple or a flat. But with this, you could actually display based on objects. But usually, you'd only get objects if you want to do something with them, not for a straight display. You just kind of choose which mode you want to operate.
Yeah, you can. Each relationship you can set to eager load or lazy load, and you can actually set that in the query. On the query object itself, there's a there's an options function.
So if you knew you were iterating deep, you just let it chunk it when it gets it. And
What happens? SQLAlchemy will issue. I think typically it will use a join, join it, and then SQLAlchemy itself will compress the duplicate rows, and so you can get your list that way. So it'll generate that kind of query. I guess there's a.
So it could actually save you speed to lazy load if it was something that would really inflate and then compress back and a small number of them. So you just have to kind of tailor it to whatever you're doing. I mean,
it definitely depends on the data, which is better, and how you're going to use it. If you're, going to be, say I had a whole bunch of albums, I selected them, and, I knew I was going to need the band for every album. It would make a lot of sense to just, go ahead and, I guess that's what I'm doing now. So it'd make a lot of sense to just, I forget the exact syntax, the exact call on this, but let's see. Let's see if I can do that.
Definitely coding on the spot.
Yep.
So you have the option not to load all of its children or associated. You could just load portions of it. Could you specify them?
I mean, it's a per relationship thing.
Yeah.
So, I don't know if you can filter the relationship further using this.
You would just put commas, and if you had multiple relationships, just chain all the ones.
I think you can. I think you can either use. It's either commas or you do
another, just a chain.
like that, or you can chain it. I forget which one it is, but you can definitely do multiple ones. And it's not selecting from the bands. Of course, that might just be because that's all in the session. Oh, except I rolled it back, so it wouldn't be. So eager loading's working there. And I guess we could look at the query here. Left outer join. So it's selecting them all, and then SQLAlchemy is compressing them back down when it comes back. So that's all I had planned so far. I guess I probably went through it quicker than I expected, but if you want to look at more stuff, the SQLAlchemy has great docs, lots of tutorials and examples. So I would suggest looking there. And there's a video here, very in-depth introduction by Mike Bayer, who authored SQLAlchemy. So if you want to really understand it, that's a very good resource, like a 2.5 hour talk or something.
Is there anything in there for doing something kind of like cursors, or would you just kind of do that on the objects and then commit it? Where you'd be going through and doing something complex per row and iterating. I know you try to stay away from it as much as you can, but sometimes that's all you can do.
I'm not. Are you talking about like server-side cursors?
Well, SQL cursors where you're kind of going through, you're taking a row and then doing maybe subqueries or custom things with it. So if you just did it with the objects, is kind of how you handle it and let it build the queries that's required for it.
I mean, I'm not overly familiar with server-side cursors. I've never had much use. Never encountered a situation where I needed that. Like you can, there may be support for that. if you fall back to the more primitive, like there's a separate expression language underneath this, which is a more primitive, more closely tied to the actual SQL. If you fall back to that, maybe you can do it, and you can always fall back to just raw SQL, and you get the connection object and just run SQL on it.
Is there a situation there where you can take an existing database? Because you created your objects that kind of represented the tables, but if you're kind of joining with an existing database, can you inflate into objects from an existing?
Yes, SQLAlchemy actually has some support for introspection and generating from the database, just generating the objects. But say I have an existing database and this isn't called ID in the database.
Right.
I can just the first argument. That would be the column name. So yeah, you can it works very well with existing database. We have a huge SQL Server database that we use this in front of, and you can customize it enough to match what's actually in the database.
I was worried at first with this that the relationships you usually put in a database to keep yourself safe, but it generates those as accurate SQL, so they already exist. So if people are getting it from non-SQLAlchemy, they're still protected by the structures you kind of set up if you build it, which is pretty slick.
You can define constraints and things as well here.
Yeah, you can.
Well, you can see them in the SQL that create the relationships. By doing the foreign keys and all that, it's going to reinforce it.
Yeah, I mean, you can define, like, there's a table args, and this is just a tuple of constraints and stuff. So I'll just say and we can define an expression there.
And for each column, then you could do the default types, kind of like the get date or those style things.
Yes,
for your initialization.
You can provide defaults. I don't know if I did that here. I did not. You can provide both client-side and server-side defaults. So
you have your own initialization function then inside there or something that would
so
that's cool. I always wish SQL could do something that you can't easily.
You can do that. It can be a callable, it can be a literal, and if you want the server side,
that's neat.
And that will generate the default on the actual SQL table.
So you would never really be in a situation where you create store procedures or anything ever. You're just you're representing them all.
We actually got rid of a ton of store procedures when we replaced some ASP classic pages, some Python. They were all backed by a bunch of store procedures. We just ripped them out, re-implemented the queries in SQLAlchemy.
The biggest issue we've always had is versioning on the database side, and seems like still the best is script out the whole database and source control
delete them all
so you have a create for every single object, and you're checking it in, and it's only doing the changes, but it's still subpar for tracking.
Keeping those two things synced, that can be a problem. So we definitely prefer to avoid having to do that at all. Just implement it all in SQLAlchemy.
Do you ever wrap kind of the queries in objects I'm trying to think of something like a view or a more complex object.
Oh, you can reuse a query.
So you may have a higher level object.
Like you can, I often have like functions that will return a query.
Okay.
And so a class method, I might have a class method on my ORM class. It says, get,
okay.
And
that makes a lot of sense. I was trying to figure out how you join the objects to the pretty prints or whatever.
Yeah. So and then I just return the query from there, and anytime I need that functionality, I just get the same query.
Okay, that makes a lot of sense. So you can have it processed.
And I mean, since queries are immutable, you could just define it as a class attribute or something.
Right.
But a lot of times, we kind of build them dynamically, sorted.
You just kind of make generator expressions, really.
Yeah. I mean, you can have like a function that generates your base query, and then, for instance, we have this library called WebGrid that will take basically like it's a table generation library, for Python, and supports a bunch of filtering and stuff, and that will generate your base query based on the columns you reference, and then it will, conditionally apply the filters that you specified. It will generate the entire query, which is, so that works great with SQLAlchemy because of, how the chaining works and stuff like that. And that definitely avoids, a very nasty situation of, generating a string query.
Do you have any feel for execution speed of queries on this versus something like PHP?
Execution speed, I mean, the bottleneck for me has always been the network and the database. So, I mean, there is overhead.
On my unit bottleneck, it's the processor on the Linux side of the unit
Well,
side.
yeah, I mean, it's the bottleneck's the database. When actually executing the query and, sending the results over the socket or whatever, that's almost always the bottleneck. I mean, there is overhead on top of that. Just constructing the Python objects. I mean, Python's not exactly a fast language. It's typically fast enough, though.
Right.
And because everything's done lazily, I mean, you can definitely save some processor time or some execution time with that.
Do you see much speed difference? I guess you're really not measuring against store procedures and things because often you can get them where the query execution plan is already compiled on the database, where everything here is a straight SQL query that's compiled at execute. And I guess it would take a fairly complex query before that really becomes a factor.
I don't know of any method of doing that. Someone may have come up with something that I'm not aware of. I mean, there's a lot of libraries in the community out there. I mean, if you're using Postgres, I mean, it does its optimization dynamically or something, so you can get benefits there if you execute the query enough. But that hasn't become an issue for us yet, so I haven't really looked into that.
It's the same argument in Python versus C still. It may be a little slower, but it's a whole lot easier to deal with.
About the performance stuff, in your example here, you're showing connections, tearing them down, and all that stuff, and rebuilding them, and new connections. Are those actual connections to the database? Is there connection pooling or session
yes,
pooling for those connections?
There is connection pooling.
Okay.
So it will reuse connections.
So it's not really just throwing the whole thing away. It's sort of
the session kind of wraps the connection, but the connection can't outlive the session. It doesn't actually necessarily destroy it. Any other questions? Anything else I want to see done with this?
It's useful for testing too. We use. Can you say anything about that?
It's pretty easy to test. I mean, what we like to do, we like to make a class method.
just a test and create method, and any required attributes that aren't given through the keyword args, we just randomly generate, randomize them, return the object, and any relationships that are required, the test and create method makes them. Make sure you don't run into not null errors or whatever.
You actually, like in your testing, you run the actual SQL queries and do a rollback. Is that your typical?
No, we actually commit it.
And then
we just have a testing database and we clean it
Okay.
up when we need to. Yeah. I've pushed for changing that to doing a rollback, but the issue
you might
is
miss
sometimes we
something,
have
but-
multiple sessions. When we do our, like functional tests, we call them, like when we test the views, like we'll have a client that has a different session than the view because we're going through the whole stack.
Mm-hmm.
And this different session therefore has a different transaction going. And so because of the transaction isolation, we need to make sure we commit the client so that it doesn't rely on the server to see the changes.
This, it seems like it's pretty easy to stand up your whole database and load test data to make a test framework.
Yep.
The Northwind load or whatever,
Yeah, and you can just change the connection string that you use and do a different database, execute it there. For a while, in one of our projects, we were deploying on SQL Server, testing on SQLite because it was so much faster.
Mm-hmm.
Because it's just
When you find your group eyes failed. When
Exactly.
yeah, that was the issue because we were having to implement things twice just so everything worked on SQLite and SQL Server, which kind of defeated the point of testing. So
when you get into a fairly large project, would you have a single file per table object
no, we group them by
functionality? Or
yeah, we group tables by kind of what they represent. We have something that's
pick the main one and all the hierarchical below it, and that's kind of one logical unit, and then
things that are related in like a business sense. The business logic we put together in one file. You can just split it across as many files as you want. Or, you could put one per file, but I don't know why you need to do that because of Python's namespacing.
right. And you're not really doing a lot of display level or any other coding in those objects because you're associating the others with it.
Yeah, there's usually, there can get to be some logic in here. Like I said, I'll generate queries off of these or something like that. But
that's all your data level.
Yeah, this is all data level.
And then you throw one of these objects into your display or a group of them and then process it for your display logic.
Yeah. Although another common thing we might do is there's a little bonus here. There's a thing called hybrid properties. I don't know if that's the right module. I can't execute this anyway, so. Hybrid property. So right here, this is, just normal property. But So yeah, that operates just as a normal property. This operates as a class property, and you return an expression from it, a SQLAlchemy expression. So it's actually a class property, and so I could return just
And that becomes something you operate on the object when you get it.
yeah, I mean, what I use this for is that I could actually add this to the query function. I can select it, and it will use the expression version, and it will just insert this expression there in place of
The post process that after it comes back from SQL, it'll kind of pin that into your setup.
Yeah, well, I mean, once I have the object, it'll call this. It won't go to the database, but I can select it. I can select this property like this, and I can use this in a filter. I can use this anywhere I would use a normal attribute. So that's kind of helpful. You can compute certain things. We do this quite a bit just because sometimes, we want to combine fields to make a better label for things.
That kind of replaces your need a lot for views then, because the views is kind of massaging a little bit as far as field changing and joining.
Yeah, sort of. I mean, you could definitely go overboard with this, but for something like just a useful label, that makes sense to me to put it on the data object, because you're going to use that a lot in a lot of places.
Is there a way to make overload an existing, if you have song, overload it as the use case I'm thinking of is logical delete, where you often have a view of a table that's only the stuff that hasn't been logically deleted but still exists in there.
Yes,
like
there
persistent
are.
filter.
Yeah, there are recipes for that. I personally don't know them, but I have seen where people do that. I think that's built-in functionality. You can say, here's the flag, or here's the expression that means it's logically deleted, and it will apply it to every query.
Got a lot of reading to do.
There's plenty of places to read.
He briefly mentioned Alembic too, which is made by the same author of this, so it works really well if you're doing migrations as you're making changes to your database. You don't have to do them using SQL. You can keep it all here and have a history of that.
Process.
Yeah, I mean the Alembic migrations kind of similar to Django's migrations. You can auto-generate them. We typically don't. We just write them because it's easy enough after the first one. And it's a real basic system. You got an update function, you got a downgrade function, and you just apply whatever. And then there's a bunch of helper functions to apply different operations. It's also got branching too, which can be kind of useful, I guess.